Okay guys, this is the last video for average atomic mass, and we're going to have to learn how to do one more type of problem, and that's called percent abundance. Sometimes they're going to give you the relative mass and ask you for the percent. And some of you might be thinking, well, how in the heck am I going to do this? I have no idea where to start. And that's what I'm for. I'm going to help you do that. The really important thing is that you'll never have these problems with more than 2 isotopes, because that we can't figure out. Okay. So let's go ahead and just dive in. The problem says, what is the percent abundance for each isotope? The average atomic mass is 238.03 AMU. So we know the average. And remember, the way we did the last problem is for the stuff we didn't know, we put an X. And we're going to do that here. The difference is I have 2 unknown variables, right? So the percent is going to be what we're trying to figure out. Here's the important thing, and this is how I can do the problem. If I have 2%, so a percent plus a percent, and I know that this is the only thing we're talking about. Maybe I did a survey and said, okay, how many people prefer chocolate? How many people prefer vanilla? And you had to pick. Okay, so the total percent is always going to add up to 100%. And so the reason I can do these problems is because of that fact. Now, remember, when we do these problems, you're always going to move your decimal over 2 places. So I'm going to say this percent plus this percent, and I'm going to use those as a decimal. It's going to equal 1. Okay, so I can call one of these percents x. And if I know one of the percents is x, what's the other percent going to be equal to? Well, I don't know the exact answer, but I can tell you that this guy will be 1 minus whatever x is going to be. So this is how you're going to do your problems. You're going to take the relative mass of the 1, and it doesn't matter which one. And I'm going to say that is multiplied by the percent. And then I know that this mass is going to be equal to 1 minus this percent. And I know that the average atomic mass of all of these added together is going to equal this, because that's what they told me. So at this point, it is a little bit trickier than what we've been doing, but you're just going to distribute this. So 235.0439x plus 238.051 minus 238.051 x. And that's going to equal the 238.03. So like we did earlier, we're going to combine like terms. So we're going to combine this guy and this guy. And in this case, you might be able to see right now that it's going to be negative, and that's okay. I have 238.051 minus 3.0071 x equals 238.03. So at this point, we have that problem like we said earlier. Remember, we said you have 4 minus 2x equals 8, and you're going to solve. That's what we have here. We need to subtract from both sides the number without the x. And now you'll see why it doesn't matter that it was negative, because now both sides are going to be negative, and it'll all cancel out in the end. So I have our x variable there, and then negative 0.021 on this side. So I'm going to divide on both sides. So x is going to be 0.0069. Let's see how many sig figs I want. I want 6 sig figs. So I'm going to keep writing here. And remember, this is the percent abundance of this first guy. And in order to change it back to the percent, I need to move it over 2 times. And then I'm going to subtract that from 100 to get the other percent. So it's 99.3107. So that is your most challenging problem. What is the percent abundance for the isotopes of copper? Isotope A. So they don't give you the data in a nice neat column, so I'm going to make one for you. And so there's your data, and we're trying to find, and they give us the average as well. The average is 63.55. Okay, so we're going to do this exactly the same way. We're going to take the first relative mass, and we're going to say the percent of that guy is X. And then we're going to take the second relative mass, and we're going to say that is 1 minus X. And then we know the average is 63.55. We are going to distribute. Okay, I'm going to collect like terms. I'm going to add this guy and this guy. Okay, we're going to subtract our non-X digit from both sides. We're going to divide. So X this time is 0.69. And I put 4 digits down because that was the fewest they gave me in the problem with the average right here. And remember that you're going to have to change that back to a percent, moving it over to. So the percent for this first guy is 69.30%. And we're going to subtract from 100 to get the other one, which is 30.70. Okay. So there's 2 examples. One was less conventional than the other one. This one is probably a little easier for you to comprehend because it has less weird numbers in it. From this point forward, you're going to have problems with any of the examples I gave you, either average atomic mass or mass contribution or percent abundance. And it's your job to figure out what kind of problem it is and to solve it. You have basically one more page to do in your packet, so 11 through 17, and then we'll move on to nuclear stuff.